So these piecewise functions, finding limits of the piecewise functions is much easier if you just draw the graph of the piecewise function. I mean, you can do it without that, but if you just take a little extra time to draw the graph, just by plotting points, if you plug 0 in, just plot the endpoints. You know these are linear. Plot 0, put 0 in for x, and you get 1. So you get the point right there, and then you plug 1 in for x, so the other end of the endpoint, and you get 0. That's an open circle. That's a straight line. Okay, and then the value of the function is 1, so that's horizontal line between 1 and 2. So we have solid circle there, open circle there. The value of the function is 2 when x equals 2. And then, what is it, x minus 1, so you plug a 2 in there, you get 1. Plug a 3 in there, you get 2. So from 2 to 3, and that's a solid circle there. 2 to 3, you get that straight line. And then this straight line, plug 3 in there, and you get 1. Open circle. And then you plug 4 in for x, and you get 0. Closed circle, and that's, again, a straight line. All of these three are diagonal lines. Here we have a horizontal line, here we just have a dot. So anyway, once you look at the graph, you see that the limit as x approaches 1 from the left, the y values are going down to 0. Okay, the y values when x is approaching 1 from the right, the y values are approaching 1. They're at 1. F of 1 happens to be 1. And then the limit as x approaches 2 from the left is 1, 2 from the right is also 1. The limit as x approaches 3 from the left, that's going to be 2. And then f of 2 happens to also be 2. Alright. And then this guy right here already is the graph, so easy to look at here. As x approaches -1 from the left, the y values are approaching 1. X approaches -1 from the right, y values are going to 2. X approaches 1, the y values are both, from both sides, are going to 1, but f of 1 happens to be 3. Okay, and then let's move on up here to the limacons. And the limacons, I know we didn't spend a lot of time in this section in pre-calc honors, but if you just did an r theta chart and you picked values of theta that start at 0, cosine of 0 is 1, so 1 plus 1 is 2, so you get the point 2, 0. Okay. The next most convenient value for theta would be pi over 2. Cosine of pi over 2 is 0, so r has a value of 1. So you go 1 unit towards pi over 2, put a dot there. And then when you plug in the next most convenient value for theta, which would be pi, cosine of pi is -1, plus 1 is 0. And then you plug in 3 pi over 2, cosine of 3 pi over 2 is 0. Again, you get 1, so you go 1 unit toward 3 pi over 2. And then back again to 2 pi, and you get 2 again. So basically you're starting here, and the graph of these polar functions, graphs of these polar functions are typically curvy and easier to graph in on the polar coordinate plane. So anyway, that's what the graph of this limacon would look like, where here this is your A and this is your B, and this would be the case where A is greater than B. A is equal to B, and A is equal to B, you get the limacon. Actually, it's a cardioid, special type of limacon that hits right there at R0, or the origin, whatever you want to call it. So then this next one, keeping the same principles, I'm not going to go through it, but it would look like this. 2 plus sine of theta, you've got 1, 2, and theta is 0. You have r is 2, and then 1, 2, 3, and then you have 1, 2, and then you have 1 right there. So the sine graphs typically are symmetrical with respect to the y-axis, or the vertical axis, and the cosine graphs, limacons, are always symmetrical with respect to the horizontal axis, or the polar axis. So limacons, I said usually, but limacons are always symmetrical with respect to the y-axis if you have an xy plane, and cosines with the x. I have to sign off.